Hi everyone. In this video, we're just going to work through some really basic evaluate the inverse trig functions. Again, what I want you thinking as you work through this is just you're really trying to drill into your brain what inverse sine does. What is it input and what is it output? And the same with cosine and the same with tangent. So what we want to think back to is sine inputs an arc length, outputs a y value, which means inverse sine is going to input a y value and output an arc length. So the question here, and you want to just train yourself to ask this. So we're saying what arc length will give me a y coordinate of -√3/2. But really there's more to it. So that was the kind of simple way to say it just to make sure you're understanding. The full statement is which arc length between -π/2 and π/2 will make my y value -√3/2. So if I'm picturing my unit circle, I have a y value of -√3/2. For starters, there are two different locations I could be at, even ignoring the period of the trig functions that allows you to get to the same location infinitely many different ways. So I could be in quadrant 3 or in quadrant 4. That -π/2 to π/2 thing automatically makes me choose quadrant 4, so I'm always going to be on the right side with sine. Even more than that, there are infinitely many arc lengths that land at this point. I specifically want the -π/3, so I don't know if that looks quite low enough on the circle, but arc length of π/3 would land me at √3/2 for a y coordinate. -π/3 will land me at -√3/2. So this gets back to just some of our memorization and practice with our special values. So you will need to keep that going, as well as keeping track of sine versus inverse sine. So which one inputs arc length, which one outputs arc length, which one inputs y, which one outputs y. All right, for inverse cosine of -√3/2, now I'm saying inverse cosine should input my x and output my arc length. So I am asking myself which arc length between 0 and pi, so for arc cosine it's always the top half, 0 to pi, which arc length between 0 and pi will land me at a point with an x coordinate of -√3/2. So again, if you're saying -√3/2 is your x coordinate, you could really be in quadrant 2 or 3. Because this is an arc cosine that's doing the asking, it will automatically force you into quadrant 2. So this is my point. And then even more than that, not only will it pick the top point, it will pick the shortest arc length to get to that point. So this little one right here. So that is going to be a 5π/6. So again, with that memorization component, we still need to know all of our special values to do this. Okay, inverse tangent of 1/3. So 1/3 is going to be my slope. Inverse tangent inputs a slope, outputs an arc length. So if my slope is 1/3, the square root of 3 is a little smaller than 2. So square root of 4 is 2. 3 is a little smaller than 4, which means its square root is a little smaller than 2. Which means I'm kind of in the ballpark of 1/2, a little bigger than 1/2, but definitely this is a slope less than 1. The bottom of this fraction is bigger than the top. So I'm picturing a slope a little less than 1/2. That might even be a little steep. Okay, and then I want to pick out the arc length that will land me at one of these 2 points. So again, the full statement is what arc length between -π/2 and π/2 for arctangent will make my slope equal to 1/3. So arctangent is automatically going to choose quadrant 1 over quadrant 3. So it's always going to choose 1 or 4. Those are the only choices. And again, even more specifically than that, it's going to choose this little arc length right here. That's what we're looking for. So I don't have my tangent values memorized, but I recognize that √3 in there. And I know I'm looking for either the π/6 or the π/3. If you're careful about your picture, you should be able to spot that this has a slope less than 1, so we're closer to the x-axis. So I'm thinking that I want the pi over 6 for my arc length, which would make my coordinates root 3 over 2 1/2. And then you can double check yourself. So you can say, all right, if I take my y divided by my x, 1/2 divided by this is the same as 1/2 multiplied by 2 over root 3. And that will give me my 1 over root 3. So you can always check if in doubt, but if you're careful about drawing your picture, you should be making a really smart first guess and hopefully have it right. So it looks like if I have an arc length of pi over 6, my slope will be 1 over the square root of 3. Okay, how about arc sine of negative 1 over the square root of 2? Okay, so again, with the notation, asking for inverse sine means the exact same thing as asking for arc cosine. So these two are not the same question because I'm being given a different piece of information, but the arc sine and inverse sine part are the same. So this is asking if my y coordinate is negative 1 over the square root of 2, what is my arc length? Which arc length between negative pi over 2 and pi over 2 will make my y value negative 1 over root 2? Okay, so memorization component here is recognizing that 1 over the square root of 2 as lining up with one of our pi over 4s. I can definitely narrow it down more than that. If my y value is negative, then it's either in quadrant 3 or quadrant 4. And because arc sine is the one doing the asking, I'm going to choose the quadrant 4 point. So I am looking for the arc length that lands me right smack in the middle of quadrant 4. So this is a great example. A lot of people will be tempted to say 7 pi over 4. And that arc length will land you there, but arc sine would never give you that choice. It would always give you the shortest distance. So it would give you a negative pi over 4. Okay, couple more. Let's see. Arc cosine of 1/2. So now I'm saying my x coordinate is positive 1/2, which is going to put me either in quadrants 1 or 4. Arc cosine, okay, so again, this is my x, and I'm looking for my arc length. So arc cosine is going to give the arc length that's between 0 and pi. Remember, cosine is different. That will make my x coordinate 1/2. So arc cosine will always choose this top point, and then it will choose the shortest possible distance to that top point. So to get an x coordinate of 1/2, I need an arc length of pi over 3. Okay, last one. Arctan of negative 1. So once again, arctangent is the exact same thing as inverse tangent. So I am inputting a slope and outputting an arc length, exactly the opposite of what tangent does. So I'm saying if my slope is negative 1, what is the arc length that got me there? So slope of negative 1 allows you to either be in quadrant 2 or 4. Because this is arctangent, it will always put you on the right side of the circle. So this is the point that I'm interested in. And then once again, it's always going to choose the shortest possible arc length. So it's going to be this one. We're not going to go all the way around the circle to get there. We're just going to go negative a little bit. And this is another with the recognition thing. So it's not so much that I've memorized values of tangent, but this one I hope really jumps out at you. If your slope is 1, then your y is equal to your x, and you're right smack in the middle. If it's negative 1, then your x and your y are opposites. So we are right smack in the middle of quadrant 4. So this one, once again, is a negative pi over 4. All right, thanks for watching.